Hi there, welcome back to Maths Lessons. Today I'm going to go through this question here where you are completing some tables of values and seeing what happens to the graph of basically y equals x squared. So that's our mama graph. So let's try these ones here. So question A, we're subtracting 1, -2 and 3, that point's there. 0, -1. Now I did ask you to do these, so hopefully this is more revision or just a check for you that you've actually achieved what you need to. Here's our parabola starting to turn around. 1, 0 here. 2, 3, 3, 8. Up there somewhere. Some people say, what if I've run out of graph to do it? Don't do it. Just use the few points that you have. Remember, it only takes 2 points to do a straight line. And it actually only takes 3 points, as long as you've got the right ones, to show a curve, as long as you incorporate somewhere the sort of the main turning point. So we have this one here. I'm going to show you how you sketch them on a graph, which is what you need to do. This is your skill you need to do. You need to come from here. No one's going to give you a table of values, and you're not going towards that. You're going towards sketching. So you can use a table of values to start with. So I've done the graph here. Now we're going to plug in some features. The turning point there is -1, 0, which is the minimum. So the fact that I'm drawing this in green on the graph is not a note for you. It's actually me drawing in the features, and I'm also going to draw in the axis of symmetry. And I'm also going to label this graph. I'm just going to use my blue pen because it's better. So this is the graph of y equals x squared take 1. That's actually part of the graph. I'm just going to remove some clutter. That's not really clutter. It's clutter notes. Okay, so we've done this one here, and let's do the second one. So you've noticed that from the mama graph, x squared -1 is almost exactly the same as what you would have had for an x squared graph, but every point has gone down 1. Okay, so the turning point has gone down 1 from the origin. So that's an important observation for you. And the next one we're going to do is this one here. Okay, so -2 and 9, it's somewhere outside our graph, so I won't bother with that one. -1 and 4 is this point here. 0, 1. Always do solid points for plotting, not dots, because once you draw the line over the top of them, the dots kind of disappear. So here I've done large circular dots. 0, 1, 1, 0. These slightly overlap onto each other. 2 and 1, 3 and 4. So now I'm going to use the black pen to trace this one. So I'm going to label it y equals x minus 1 bracketed squared. So the difference between these two graphs in the formula is we subtract 1 and then we square it. So if you had trouble with this table, maybe you just had to rethink that. And the first graph was we square the x and then take 1. So you should observe from this that the second graph, where we subtract 1 before we square it, this black one here, we actually get a sideways shift, a right shift. So maybe that's not what you expected, but let me tell you something here now. Let me tell you, I sound like a mum. Let me give you a good important note that's going to help you. So y equals ax take b all squared plus c is the general form of a turning point equation, or the equations that we're using here. The A value is the fat skinny, so that changes the shape. The number inside the bracket before we square is the left-right transformation. And the number that we tack on the end of squaring is the up and down or the vertical. Okay, so this one's horizontal transformation and this one's the vertical. And this is the shape. So remember the shape 1 along 1 up, 1 along 3 up. So we get some kind of variation on that if we have a coefficient or a number in front of our equation. So you can see that the black graph, the -1 gave us a right directional shift from 0, 0, the origin, of 1 shift to the right. We'll call it the red graph here, graph A. We had the plus, the -1 at the end, so that gave us a drop of 1. Let's take a look. Okay, so make sure that your graphs are labelled with the equation of the graph. Make sure you're showing the axis of symmetry, which I haven't actually done with my second graph, so I'm just going to put the axis of symmetry in there now. I'm just going to circle the turning point, and I might actually put over here minimum equals 1, 0. That's the main feature. The shape hasn't changed, and anyone that knows quadratics that will be looking at these can actually just look at your graph and notice that it's the shape of a regular parabola, the one along 1 up pattern. Okay, so they're not squished in any way, and we're showing enough points there. For these ones here, we're going to look at combinations of shifts going on. So we're going to be plotting y equals x plus 2, all squared, take 3. And then also on the same axis, we're going to go x minus 1 squared, add 2. So you can certainly fill out this table of points, but I'm going to show you how you can sketch these two equations, these two parabolas, based on mama graph of y equals x squared, of which we know the pattern 1, 1, 1 out, 3 up. Okay, and the other same on the other side. Okay, so if you choose to fill out these points, and I encourage you to do that, you will get this set of points here. And the other one I'll fill in here. Now you can certainly go along and plot pairs of coordinate points. However, the skill that you actually need is to be able to eyeball the equation. And if I write the first one down, y equals x plus 2 squared, take 3. The number inside the brackets is my left-right shift, my horizontal. And because it's plus 2, I'm actually going to go 2 clicks to the left. I'm going to go minus 2. My number outside the bracket is minus 3, and that's just the straight vertical shift, up or down. Now it's minus 3, it's just straight down 3 steps. So in the graph, from my origin here, I'm going to go 2 to the left for the plus 2 in the brackets, and then I'm going to go 3 down. Now that one there is my new turning point. My graph should annotate and label the key features. So my turning point is a key feature. In this case, it's a minimum because it's a right way up parabola, and the value is -2, -3. So I've clearly labeled that. I don't actually need to plot any other point now. I can just use this shape here and just step out 1 along 1 up, 1 along 3 up. Another one to the right, 1, 2, 3, 4, 5, just gets it in that graph. I don't care if it's not quite on this graph here, because it's enough there just to plot a sketch. So it's going to grab a different color pen. I'm going to come to there for sure and plot this guy here. I have to label all my graphs. That means you have to label them too, not just me. Okay, so that's what we have to do to show good sketching of these. I'm going to put in my axis of symmetry. please use a ruler. Okay, that should be straight line. I've labelled my turning point. Now that's all I need to successfully sketch that graph. So I've basically mapped if I can do a pointer, I've basically mapped my mama graph onto the coordinate planes showing all the shifts. Next one, I'm again not going to use the table of points. I'm going to use the equation. I have a -1 shift, and that means from the origin I'm going one step to the right onto 1 for the x, and then the 2 is a 2 directional there. So 1 to the right, 2 up. So my new turning point, or my turning point for this equation, is this point here, 1, 2, and that's my minimum. From there, sketch. Couple of points either side. Then I take my pen, take a different colour. I'll take black, and I always go past the last point, like that one there. So I just go a little bit past each one. I'm going to label the graph y equals x take 1 all squared plus 2. So in this lesson here, we have done some further plotting of quadratic equations on coordinate graphs. We've gone into the next lesson, however, because I've shown you the tricks for sketching. So when we have this form of a quadratic equation, we take the horizontal shift, the up and down shift. Now just a note, the horizontal shift is actually a little bit counterintuitive. If some of you have been on a boat, you know, with a rudder style, and you steer the boat, you know how you turn the wheel to the right for the boat to actually go, or to the left for the boat to go right? That's a bit how these work, okay? So if you're subtracting a value from x, you're actually kind of like heading to the right directional for that. And you should believe that, because if you plot the points, that is actually what you get when you get that winding shift before you apply the squaring operation. Okay, so there we go. So that's the horizontal shift, the vertical shift. I'm also looking for a number in front of a. These particular two equations, C and D here, do not have a coefficient other than 1 as implied. So the shape of the graph, we can just sketch it out. If you head back to the OneNote, you can actually complete the rest of section 11.3, questions 1 to 3, I think it is, and look at the next lesson where you no longer have to do these tedious tables. I would certainly encourage you to do them if you feel you need to, but you can move on to the sketching method. All right, hope your day's going great, guys. Talk to you soon. Send me an email if you have any questions about this work. Bye.